Okay. So we take the phenomena of photoelectric effect. So the photoelectric effect is the emission of electrons from a metallic surface from a metallic surface by use of light by use of light or radiant energy light or radiant energy of certain minimum frequency is called as photoelectric effect. So it is called as photoelectric effect. So that means so we are taking a sample like alkali metals. We are taking a sample, and when we incident some photons, so then the photon is able to eject out an electron. So when the electrons are emitted, so this phenomena is known as photoelectric effect, and this emitted electrons are known as photoelectrons. They are known as photoelectrons. Next, we think of work function. We used to think of work function. So first you need to understand the basic terminology here. Work function. So work function in physics we will use W symbol, and in chemistry we will use phi. So whatever may be the case, work function is nothing but this is the minimum energy. This is minimum energy needed. This is the minimum energy needed to remove electrons. From metallic surface. Is defined as work function. So this is nothing but this is the minimum energy needed to start the photoelectric effect. So you are taking W equivalent to H nu naught, or that equivalent to Hc by lambda naught, where you are calling as mu naught is threshold frequency, and lambda naught is threshold wavelength. Or we can understand W equivalent to H is the Planck's constant and C is the light velocity we are taking. So we need to take 12,400 electron volts angstroms. The equivalent value of Hc is 12,400 volt electron volts by lambda naught. So this is very important principle, which is used to convert easily from wavelength to work function. So here, whatever may be the work function obtained, generally it lies in electron volts. So actually we are defining the metals. Metals means actually this work function, especially out of all metals, work function is minimum for alkali metals. So this is minimum for alkali metals. So this is W is minimum out of all elements is cesium. W is minimum for cesium. So it have a value of 1.9 electron volts. Or simply you can understand that work function is nothing but it is the equivalent to, in your chemistry term, first ionization potential, energy needed to remove an electron. You can think like this. So first you need to understand that for a given material, for a given metal, work function W is equivalent to constant. For a given metal, work function W is equivalent to constant. So this we need to understand. So after taking the work function, we used to think of threshold frequency. Threshold frequency. Threshold frequency mu naught. So threshold frequency V naught mu naught means, actually according to the formula we defined W is the minimum energy. So automatically while you are defining the nu naught, so the nu naught also has to be minimum. So therefore we will say that the minimum frequency of incident radiation, the minimum frequency of incident radiation required to eject the electrons, the minimum frequency of incident radiation to eject the electrons from metal surface is known as mu naught. Generally, we have a relation mu naught equivalent to we write C by lambda naught. Already we discussed lambda naught is the threshold wavelength. Lambda naught is nothing but threshold wavelength. Suppose this is situation I'm taking. If incident frequency, so let us say nu, that is nu is less than mu naught, then there is no photoelectric effect, because we are taking that nu naught is the frequency to start photoelectric effect. Nu naught is this frequency to start photoelectric effect. But you are thinking of a frequency even less than that frequency. So therefore the photoelectric effect is not possible. We are taking. And so for metals generally, for metals we are taking. So this lambda naught lies in the order of 200 to 300 nanometers. So which lies in UV region, ultraviolet region we are having. And when we take cesium oxide, so this lambda naught, it is having a value 400 to 700 nanometers. These values are important. So this lies in visible region. So this is the minimum frequency. Simply we will understand that this is the minimum frequency to begin photoelectric effect. This is the minimum frequency to begin photoelectric effect. So next we are taking threshold wavelength actually. Next I am taking threshold wavelength. In some theory questions, the definition is very much important. So that's why we are stressing W equivalent to Hc by lambda. So according to the definition, we are taking that work function is the minimum energy. When the work function is minimum, so the lambda naught to be defined in terms of maximum wavelength. So therefore, simply we are writing this is the maximum wavelength. This is maximum wavelength. This is the maximum wavelength of incident radiation. To start photoelectric effect. Photoelectric effect. And so that means that is the maximum value. So that means beyond that there is no photoelectric effect. Suppose I'm taking if incident wavelength lambda more than lambda naught. If incident wavelength is more than lambda naught, so photoelectric effect is not possible. We are taking. So then we used to think of a term photocurrent. So next we will take photocurrent. Photocurrent, small I. So when we think of photocurrent, small I, so simply the current flow in the circuit due to photoelectrons. So we will take I equivalent to Ne by T. So where N is nothing but number of photoelectrons. Number of photoelectrons. Simply we can understand that this is the number of electrons emitted. This is the number of electrons emitted from the given surface. So actually, in order to understand theories, or in order to understand the graph, or even in order to understand the problems, so we need the experiment. We need to understand the experiment mandatory. So we are taking the experimental setup. So this is experimental setup for photoelectric effect we are taking. Experimental setup for photoelectric effect we are discussing. Photoelectric effect. Suppose when instant radiation, suppose I am taking this is the instant radiation, falls on alkali metal surface. When instant radiation falls on metal surface, so then photoelectrons are emitted. So here it is a habit that every photon is able to eject out a single electron. So these electrons, they used to start to move from this cathode, and slowly they will move to the anode. So the anode start attracting the electrons. Actually, we will provide a potential difference, a high potential difference between the cathode and anode. Or in other words, the cathode is also called as, in theory bits, the cathode is also called as emitter. This is emitter of electron, and this anode is known as, it is collector of electrons. It is the collector of electrons. So actually, we need to understand that when potential difference V between cathode and anode increase, when the potential difference between cathode and anode increased, the photocurrent increases. The photocurrent increases. The photocurrent increases till saturation is reached. Till saturation is reached. So that means, suppose initially if you emit 100 electrons, so out of that 100 electrons, total number may be attracted by the anode because of its low potential. So when we go on increasing the potential, so the photocurrent increases, and actually it may take saturation. So next, the important point is, actually until now you are providing positive potential to the anode and negative potential to the cathode. So when you are starting, when you are beginning to reduce the anode potential, and when you are making that potential as negative, so let us see what happens. When polarity of battery is reversed, so therefore what happens is the electrons, they start moving. The electrons start moving back to the cathode. They are moving back to the cathode. So then what happens is electrons collected at anode decreases. So automatically photocurrent decreases, and finally it will become zero. So here you need to understand that for a negative potential, for a negative potential given to the anode, where photocurrent equivalent to zero, or it stops receiving electrons, it stops collecting electrons, known as stopping potential. It is known as stopping potential we are taking. So generally, we will represent the stopping potential by V naught. Stopping potential V naught. Here, these points are, the upcoming points are very important. So, what is the minimum kinetic energy of the electrons? They will ask for minimum kinetic energy of electrons. So, minimum kinetic energy of electron is equivalent to zero, because whenever the incident energy is enough to remove an electron, of course the electron is ejected out, but with the kinetic energy as zero. So that is its example. And we are taking maximum kinetic energy of electron. So that equivalent to, we used to write VQ. Instead of VQ, we are writing. So V means we are taking, V means as a negative V naught and Q means minus E. So finally we get EV naught joules. EV naught joules we are taking. So next we will analyze the graphs. So this is very, very important. The students will confuse often here. So we are taking laws of photoelectric effect. But before discussing the laws of photoelectric effect, so for a while we will focus on intensity of radiation, intensity of light. So first I am taking intensity of light. So this is very, very important to understand. Intensity of light is I equivalent to, generally what is the formula is energy by area into T, energy by area of observation into T. So energy means energy of photon. Suppose if we are having n photons incident on the surface, so then we will take n into h nu. By area of observation is yes, no issues. By T we will take. Here the most important thing is the intensity basically depends upon number of photons and frequency. So you need to understand it very carefully. So intensity depends upon number of photons and as well as frequency. So I, N and nu, all these three are variables. But in physics, we are able to understand only the relation between two parameters. So that means, so while we are studying about intensity, this is very, 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 very important point. So while we are discussing about intensity, so we keep frequency as constant. This is most important thing. And also the thing is, while we are discussing the relations about the frequency, suppose what happened to the photoelectric effect when the frequency changed means, if we are discussing such questions, so generally you need to understand that we keep intensity, that is I as constants. So this is very, very important, photoelectric effect class. So first one I am taking, for each metal, it has its own work function, threshold frequency and wavelength. And already we discussed, so W is different for different metals. So W is different for different metals, different metals, different metals, and so it is independent of intensity. How great the intensity may be. How great the intensity may be. So just now we have taken, while we are discussing about intensity, we are keeping the frequency as constant. We are keeping the frequency as constant. So therefore W is different for different frequency. Simply W is depends upon only nature of the given sample, and it is independent of everything. It is independent of intensity, number of photons or frequency, whatever. So the second one we are taking, so that is photoelectric effect. Photoelectric effect is one photon and one electron phenomena. So that means a single photon is able to eject out a single electron. A single photon can able to eject out single electron. So that means a single photon able to eject out a single electron. Eject out a single electron. Suppose after ejecting the electron, if the photons have energy, after ejecting electron, if the photons has energy, photon has energy left with, then that given that pass on to given to emitted electrons. That given to emitted electrons. So generally, it appears in the form of kinetic energy of ejected electron. Kinetic energy of ejected electron. So next one we are taking, this is the third one, the next one. So this is very important, intensity of radiation, intensity of incident radiation we are taking. Just now we have taken intensity equivalent to number of photons energy by A into T. A into T. Or some people may call it as N into E by A, where small n is number of photons emitted. Number of photons emitted per second. So when this is the expression, and also we are thinking of photocurrent. Photocurrent also just now we have seen I equivalent to Ne by T, or simply we will write Ne. So we need to keep in mind that whenever intensity increases, automatically the number of photons increases. We know that every photon is able to eject out a single electron. So therefore, number of electrons emitted increases. Whenever the number of electrons increases, automatically photocurrent increases. So therefore, simply we will say that small I is proportional to capital I. Small I is proportional to capital I we are discussing. The photocurrent directly depends upon intensity. The photocurrent only depends upon intensity. So that is very, very important. The photocurrent only depends on intensity. The photocurrent only depends upon intensity and independent of frequency, or wavelength of incident light. Frequency and wavelength of incident light. the maximum velocity, the maximum velocity of photoelectrons, the maximum velocity of photoelectrons are Ke maximum. Ke maximum only depends upon frequency of instant light. Frequency of instant light. This is very, very important point. So frequency of instant light. So here we are going to see, of course, in the form of Einstein photoelectric equation. So later we will study it as h nu equivalent to work function plus Ke maximum. So from this equation, it is very clear. H nu equivalent to W plus EV naught, like this we will write. Suppose whenever the frequency increases, so that increment will be shifted to the kinetic energy, will be shifted in the form of kinetic energy, because we know that the work function is constant. The work function is constant here, and the work function is constant. So whatever may be the increment in frequency we have, it appears in the form of increase in velocity, increase in kinetic energy, increase in stopping potential. So this is very important. And we need to understand that Ke maximum is independent of intensity of light. K maximum is independent of intensity of light. So we know that intensity also depends upon distance. So therefore, again we are writing as Ke maximum is independent of distance. K maximum is independent of so the distance from the so this metallic surface. The distance from the metallic surface. Similarly, stopping potential V naught, only depends upon intensity of light. Stopping potential only depends on intensity of light, and V naught only depends upon frequency. And V naught independent of intensity, and also V naught independent of distance of separation. So these are very important laws of photoelectric. And also the most important thing is there is no time lag. There is no time lag between incident photons and ejected electrons. There is no time lag between incident photons and ejected electrons. So next we are focusing on Einstein photoelectric equation. So we will think of Einstein photoelectric effect. So whenever a frequency of nu falls over the surface, some part is used to remove the electron, and the remaining part appears in the form of kinetic energy, Ke maximum. So this is our beside the equation. It is called as Einstein photoelectric effect. So first we will analyze the term. So we will analyze the terms and later we will think of the possible parameters. Okay, first I'm taking incident energy. I'm taking in incident energy. So depending upon the question, we may use it as E, or we may use it as h nu, or we may use it as hc by lambda. But if we need the energy in the form of electron volts, simply we will write 12,400 electron volts angstroms by lambda. So by using these possibilities, we are going to get the number of ways. So next I am thinking of work function, work function, work function W equivalent to, we may write H naught. When the answer is in the terms of mu naught, we will use that. So we will write in the form of Hc by lambda naught, or else we will write 12,400 electron volts angstroms by lambda. So we may take that way. And at the end, we are taking Ke maximum. In the end, we will take Ke maximum. Ke maximum is equivalent to, we will take half E maximum square, and that equivalent to EV naught. Or when we think of kinetic energy, we will write H nu minus W. So these are the possible forms for the Einstein photoelectric effect equation. So I'm writing some simple forms. So H nu equivalent to W plus Ke maximum we are taking, or we will write H nu equivalent to H naught plus Ke maximum, or Hc by lambda equivalent to Hc by lambda plus Ke maximum, and Hc by lambda equivalent to Hc by lambda naught plus Ev naught, depending on the need. So we may take number of ways. Hc by lambda equivalent to Hc by lambda naught plus, instead of Ke maximum, so we will write half n V maximum square. Half n V maximum square. So now we will analyze the graph. Okay, next we are taking characteristics of photoelectric effect. Characteristics of photoelectric effect. So already we have seen the first character, that is we have discussed small I is proportional to capital I. Small I is proportional to capital I. So when we plot a graph between photocurrent and intensity, this is small I and this is capital I, as it is in the form of y is proportional to x. So therefore we are going to get a straight line passing through origin. Okay. So after that, so when we think of the relation between photocurrent and voltage. So here I'm plotting a graph. Suppose on x-axis we are taking voltage. So this will be minus V naught. This will be minus V naught. This is current. This is current I. This is current. We are taking the graph between current I and voltage V. Current I and voltage V. So as we discussed it in the beginning, the theory session, as the voltage increases, first 100 electrons are emitted, but only 20 electrons reach the target, that is collector. So when you increase the potential, so slowly the number of collected increases, the number of collected electrons collected increases, and it reaches saturation. Saturation means maximum. So we need to understand this is saturation. So that is saturation level. Saturation. So this is for a particular frequency. And we need to understand that for a particular frequency I, the photocurrent remains as constant. the photocurrent remains as constant. In the beginning, we have some lapses, but at the end, the photocurrent remains as constant. As long as you keep the intensity constant, we can see that the photocurrent is constant. But whenever you go on decreasing the potential, positive potential given to the anode, and automatically we have seen the photocurrent decreases. The photocurrent decreases, and for a particular negative values, it will decreases. So this we are taking stopping potential. This we are taking stopping potential because this is the origin, this is the negative voltage. So this is the particular scenario. Suppose if we increase the intensity, automatically the photocurrent increases. Suppose this is the case I am taking for 2i. Suppose if you increase the intensity for 3i, the photocurrent also increases. You can see here, you can see with my hand. So when I increases, intensity increases from I2 to I, so the respective photocurrent also increases. When intensity increases from 2i to 3i, the respective current also increases. But in all of the situations, we can see that the stopping potential is constant. The stopping potential is constant. So the stopping potential is constant means just now we have studied. While we are discussing about intensity, we always keep the frequency as constant. So as you keep the frequency as constant, automatically just now we have seen the stopping potential also remains as constant. The stopping potential. Next, we will think of frequency, effect of frequency. Effect of frequency. As we know, as we just discussed, so as long as you discuss the variation of frequency, we will keep the intensity as constant. Whenever you keep the intensity as constant, automatically the photocurrent as constant. So simply we will see from this equation h nu equivalent to W plus Ke maximum. Suppose when you increase the frequency, work function is constant, automatically Ke maximum increases or stopping potential increases. So that we are going to see in the form of a graph. For example, I am taking this graph. Now I am taking this is a graph between the current I and as well as voltage. So we are treating that as the intensity is constant, the photocurrent is constant. Or you may take the on x-axis. On x-axis we are taking anode voltage, or you may write it as anode voltage. So we will see that when the anode voltage given slowly decreases, and sometimes it may become zero. So this is minus V0. So this is the situation we are taking for a frequency 1, mu1, let us say. Therefore, the stopping potential is 1. Just now we have discussed, as the frequency increases, automatically the stopping potential also increases. So therefore, I am taking another representation. For example, if you are thinking of another frequency, so we may get like this, the graph get like this. So this is another discussion. And we are taking another approach. For some more higher frequency, we may get the graph. So now we will analyze these parameters. So this is the situation for nu2 frequency. For nu2 frequency, we will get stopping potential minus V0. and this is nu3 frequency. For nu3 frequency, we will get the stopping potential as minus V0 minus V0. So from this, it is very clear that whenever you change the frequency, only Ke maximum changes or stopping potential changes. And we are seeing that the photo current I is constant and as well as intensity is constant. So we are taking effect of photometal. Effect of photometal. So that means in the present situation, we go on changing the photometal by go on changing the photometal. So let us see what happened to the nature of different parameters. So here the thing is intensity, both intensity and as well as frequency of light. Both intensity and frequency of light are fixed. So that means intensity is fixed. So we will set the graph for different fixed frequencies. Different fixed frequencies we use. For example, first I'm plotting the graph. Okay, this is stopping potential V0. On the x-axis, we are taking frequency of incident light. Frequency of incident light we are taking on the x-axis. On the x-axis, we are taking the frequency of incident light. Okay. Now we will see the nature of graph. Actually, we need a relation between V0 and nu. So I'm writing h nu equivalent to W plus EV0. Therefore, EV0 equivalent to h nu minus W, but V0 equivalent to h by E into mu minus W by E. So simply this is in the form of, just now we know the basics. We will write in the place of Y0 by Y. We will write letter X in the place of mu. So Y equivalent to మనకి ఎలా ఉంటుందంటే mx plus c. The slope is positive here, but it is having negative y intercept. మనకి ఇక్కడ నెగటివ్ y intercept తో గ్రాఫ్ అనేది స్టార్ట్ అవ్వాలి. సో అందుకే మనం గ్రాఫ్ ఎలా తీసుకుంటామంటే, so we will take like this. So this is the graph and it have a particular frequency, let us say mu01 threshold frequency, and this is for metal 1. Suppose I am taking this is for metal 1. Next I am taking another straight line with somewhat of difference. Difference threshold frequency. This is a mu02 and this is the case for metal 2. Just only by observing the graph analysis, so simply we will find out. So here you can see that the negative intercepts on y-axis. So here you may see that this is the negative intercepts. So on the basis of these graphs, so the people only used to think of the nature of slope. So slope of graph, when we take slope of graph equivalent to h by E, so that is equivalent to constant. H and E constant, this is constant for all metals. Next we are taking the graph between Ke maximum and incident frequency. So we will get similar type of graphs. Incident frequency. So we are writing the frequency equation h nu equivalent to W plus Ke maximum. Or if you need the expression for Ke maximum, we will write h nu minus W. h minus w. So then instead of k maximum we are writing y, and instead of frequency we are writing x. Now we are going to see the graph right now. For example, this is the y-axis on which you are taking ke. So this is ke maximum we are taking, ke maximum, and this is frequency of incident light, the frequency of incident light. So simply we can see here y equivalent to mx plus c, the same story. The slope is positive, the slope is positive, but the y-intercept is negative. The y-intercept is negative. So here I am able to draw the first graph. This is mu naught of 1. And of course, if you are interested, we can take the y-intercept as W1. W1, this is the W1 we are taking. And also, we are taking the graph for another metal. So this is for another metal we are taking. So this is stopping potential mu naught 2. So this is the case for second metal, metal 2, and this is the case for metal 1. And we can see that this is the value of work function. This is the value of work function for the second metal. So the people only ask, they are worried about the slope. Slope is nothing but h. H is equivalent to constant. Generally, in this present scenario, we are having, they may ask like the like what is the relation between slopes? Slope 2 is to slope 1 they will ask. So that is h is to h, that is equivalent to 1 is to 1. So that is equivalent to 1 is to 1. Okay. Now we will see some examples. Suppose I am taking a problem when radiation of wavelength, when radiation of wavelength lambda is incident on metallic surface, the stopping potential is 4.8 volts. The stopping potential is 1 second. Okay, we will see when a radiation of wavelength lambda is incident on a metallic surface, stopping potential is 4.8 volts. If the same surface is illuminated with double the wavelength, the stopping potential is 1.6 volts. First, మన ఐన్స్టీన్ ఫోటోఎలెక్ట్రిక్ ఎఫెక్ట్ ఈక్వేషన్ తయారు చేసుకోవడం అనేది నేర్చుకోవాలి. సో ద బేసిక్ ఫార్మాట్ ఈస్ E equivalent to W plus K or K max. ఈ ఇన్సిడెంట్ ఎనర్జీ అనేది ఏ ఫామ్ లో ఉంది? వేవ్ లెంత్ ఫామ్ లో ఉంది. సో therefore I'm writing it is in the form of h lambda equivalent to. సో we need threshold wavelength అన్నారు. సో వర్క్ ఫంక్షన్ మనం ఏ టర్మ్స్ లో మార్చుకోవాలి? లాంబ్డా నాట్ టర్మ్స్ లో మార్చుకోవాలి. h lambda నాట్ ప్లస్ కైనెటిక్ ఎనర్జీ ఏ టర్మ్స్ లో ఉంది? ఎలక్ట్రాన్ వోల్ట్స్ టర్మ్స్ లో, వోల్ట్స్ లో ఉంది. స్టాపింగ్ పొటెన్షియల్ టర్మ్స్ లో ఉంది. ఇది ఇక్కడ లాజిక్ ఏంటి అంటే మనం దేన్ని ఎలిమినేట్ చేయాలి అనేది ఆలోచించాలి. సో క్లియర్లీ యూ కెన్ సీ దట్ initially they are having wavelength lambda. In the second case we are having double the wavelength. సో దేన్నైతే మనం ఎలిమినేట్ చేయాలో అది లెఫ్ట్ సైడ్ ఉంచుకోవాలి. సో ఆటోమేటికల్ ఇన్ దిస్ ప్రాబ్లం మనం వేవ్ లెంత్ ని ఎలిమినేట్ చేయాలి కాబట్టి వేవ్ లెంత్ ని మనం లెఫ్ట్ సైడ్ తీసుకోవడం జరుగుతుంది. సో therefore I'm writing hc by lambda equivalent to hc by lambda naught plus the first stopping potential is 4.8 electron volts. Similarly, we are taking hc by 2 lambda equivalent to this is you are taking hc by lambda naught plus the second case is 1.6 electron volts. 1.6 electron volts. ఇక్కడ మనకు ఆన్సర్ తీసుకుంటే మనకు ఆప్షన్స్ బట్టి మనం వెళ్దాం. సో ఇక్కడ లాంబ్డా నాట్ అనేది ఆన్సర్ లాంబ్డాస్ లో ఉంది. ఇన్ దిస్ క్వశ్చన్ లాంబ్డా నాట్ అనేది లాంబ్డాస్ లో ఉంది. సో ఇప్పుడు ఏం చేయాలి? ఎలిమినేట్ చేయాల్సింది నెంబర్ని. ఆ నెంబర్ని ఎలా ఎలిమినేట్ చేస్తాం అంటే we may take it as equation 1 and we may take it as equation 2. We will multiply with 3 by the second equation. So సో చేసి మనం సాల్వ్ చేయొచ్చు. నేనేమంటున్నానంటే దానికన్నా సింపుల్‌గా ఇప్పుడు లాంబ్డా నాట్ కావాలి లాంబ్డా టర్మ్స్‌లో. మిగతా అక్కర్లేని పదం ఒకటి ఉంటుంది. దాన్ని ఎల్‌హెచ్‌ఎస్ ఉంచుకుంటే బెటర్. అంటే ఇలాగా 4.8 ఈజ్ ఈక్వలెంట్ టు హెచ్‌సి బై లాంబ్డా ఈక్వలెంట్ టు హెచ్‌సి బై లాంబ్డా మైనస్ హెచ్‌సి బై లాంబ్డా నాట్. And we are taking 1.6 is equivalent to hc by 2 lambda minus hc by lambda naught. So this is equation 1. We are multiplying with 3. 4.8 is equivalent to 3 into hc by 2 lambda minus we will get 3 hc by lambda naught. So simply I am taking this as equation number 3. This is equation number 3 and this is equation number 4. So simply by dividing this equation 3, by dividing this 3 by 4, we will get 3hc by 2 lambda minus hc by lambda equivalent to 2 into hc by lambda naught. Or simply by solving that we will get lambda naught equivalent to 4 lambda. So here I am taking K1 and K2. K1 and K2 are maximum kinetic energies. Maximum kinetic energies of photoelectrons emitted when light of wavelength lambda 1 and lambda 2 respectively incident on metallic surface. If lambda 1 equivalent to 3 lambda 2, then compare the kinetic energies K1, K2. First try to understand the question. First I am writing the basic equation, that is simply E equivalent to W plus 2. Energy means it is in the terms of hc by lambda. Work function is W and plus K is K1. So we have a theory relation between K1 and K2. The answer is in the terms of K1 and K2. K1 is greater than K2, K1 is less than K2, along. So అలాంటప్పుడు మనం దేన్ని ఎలిమినేట్ చేసుకోవాలి? వర్క్ ఫంక్షన్ ఎలిమినేట్ చేయాలి. So therefore I am writing the work function W equivalent to hc by lambda 1 minus K1. Next, similarly for the second case, W equivalent to hc by, so this is lambda 2 minus K. So we are dividing the equation 1 with respect to equation 2. So therefore 1 by 2 I am taking. So that is W by W implies hc by lambda 1. Lambda 1 means that is 3 lambda 2 minus K1. By hc by lambda 2 minus K. సో ఇక్కడ మనకు అవసరం లేని వర్క్ ఫంక్షన్. క్వశ్చన్ క్లియర్గా చూస్తే K1 K2 రిలేషన్ కావాలి నాకు. వర్క్ ఫంక్షన్ అనేది అవసరం లేదు. సో నేను వర్క్ ఫంక్షన్లో ఎల్హెచ్ఎస్లో తీసుకున్నాను. తీసుకున్న తర్వాత రెండింటిని డివైడ్ చేస్తున్నాను. సో W get cancelled and we will get a relation like this. So that is or else we will do one thing. We need lambda 2s cancel అవ్వాలి. వర్క్ ఫంక్షన్ రిలేషన్స్ మనం తీసుకుందాం అనుకోండి. అప్పుడు ఇలా రాసుకోవచ్చు W by W. So by solving this we get W plus K2 is equivalent to 3W plus 3K1 or K2 equivalent to 2W plus 3K1. ఇక్కడ క్యాన్సిల్ అయ్యేది λ2 ఉన్నాయి, ఈజీగా క్యాన్సిల్ అయ్యేది. ఎందుకంటే ఇక్కడ గ్రేటర్ లెస్ దాన్ సింబల్ రిలేషన్ అనేది కావాలి మనకి. సో K2 ఈజ్ గ్రేటర్ దాన్ 3K1 రాస్తున్నాను. సో K2/3 ఈజ్ గ్రేటర్ దాన్ K1 అనేది రాస్తాను. సో ఇలా మనం ఈజీగా చేయొచ్చు.